In this lesson, we are going to be looking how to graph absolute value functions, and then we're going to transform them. We're going to take those functions and we're going to shift them vertically and horizontally. So first of all, let's just look at what an absolute value function would look like. Just for a little background, we see the f of x right here. Remember, f of x can be used in place of y. It means that this is a function. It means that when graphed, the x will not repeat and it would pass the vertical line test. So it works just the same way as if it said y equals. It just means that yes, this is indeed a function. So to create the order pairs, we have an equation right here. F of x is equal to the absolute value of x. So we're going to take x and plug it in and ask ourselves, what is the absolute value of -3? And the absolute value of -3 is 3. What's the absolute value of -2? What's the absolute value of -1 and 0 and 1, 2, and 3? So to find our order pairs here, we just took this equation, the absolute value of x. We took the absolute value of each one of these. And now we have the order pairs, and we can graph those order pairs. So we go over here, -3, 3, -2, 2, -1, 1, 0. There's the 7 order pairs that we found. And when we graph it, it looks like a V. This is what a absolute function graph will look like. And if you look here, we're going to answer some questions about it. First of all, where is the vertex? When graphing these, it's all about locating the vertex. The vertex is where the two lines come together, or where the point is. So the vertex on this one is right here at 0, 0. You need to be able to identify where the vertex is. The vertex of this is called the parent absolute value function. We call it this because this is the simplest absolute value function that there can be. You have the vertex at 0, 0, and this equation, the absolute value of x, is the simplest equation that you can have. So this is the parent absolute value function, vertex of 0, 0. And what is the slope? The slope on this, if you start at the vertex, each time it goes up 1 over 1, up 1 over 1. So the slope is 1 over 1, or 1. So that's, again, why it is the simplest absolute value function, vertex of 0, 0 with a slope of 1. Let's talk about and review what the domain and range would be. Remember, domain is the x values, or the x-axis, and the range is the y values, or the y-axis. So if you look at the function up here and notice that there's arrows at the end of each one of the lines, so this line would go indefinitely to the left, this line would go indefinitely to the right. So where would it encompass, or where would it cross on the x number line here? Well, it would go to infinity to the left and to infinity to the right on the x-axis. That is the domain, so we say the domain is all real numbers. For the range, look at the y number line. This function starts at 0 and it's everything above it but not below it. So we write that as an inequality and we say that the range, we use the letter y, is greater than or equal to 0. Now we're going to take this parent function and we're going to learn how to shift it left and right and up and down. This absolute value function is a little more complicated. Notice that we actually have some mathematical things that we have to do, but again, we're going to plug in the x values to x and we are going to solve. So in the first one, that would be taking the absolute value of -6 plus 3, which is a -6, but the absolute value would be 6, and 6 minus 5 is 1. The absolute value of -7 plus 3 would be -4, but the absolute value is 4, and 4 negative 5 is -1. -5 plus 3 is a -2, so the absolute value would be 2. 2 minus 5 is a -3. -3 plus 3 is 0, and 0 minus 5 is -5. -1 plus 3 is 2, and 2 minus 5 is -3. So what I'm doing is I'm plugging in the x values and I'm solving. I've created some order pairs here. Now let's graph these and see what they would be. -9, 1, -7, -1, -5, -3, -3, -5, -1, -3, 1, -1, and 3, 1. And if you were to graph that, you will see that it looks like this. Now, we're going to find a much easier way to graph this without having to make this huge t-chart. I want you to look at the vertex of this new function that we just graphed. Here is the vertex. That ordered pair is -3, -5. Now I want you to look up here to the equation and look what we have. Notice that here associated with the x we have a +3, but in our ordered pair we had a -3, so we had opposites there. Here in what would be the y-intercept, what we use like when the y equals mx plus b, you know how that last number was the y-intercept? So we kind of associate this last number with y. Look what it is down here for the y, -5 and -5. It's not actually, if you look at the graph, that's actually not crossing the y-intercept at -5, but that's the position that we have the y. So here's the x, here's the y. Notice that it took the opposite of the x and kept the y. You can actually find the vertex by just looking at the equation this way. It shifted 3 units to the left, and it shifted 5 units down. Here is your basic absolute value equation. Now, what we're doing is we're going to look at the last number. The last number of this equation is going to be a number that shows you the shift on the y-axis, up or down from the parent function. So, if this number said +3, it would be shifted 3 up. If it says -5, it would be shifted 5 down. Whatever it says, up or down, plus or minus, it tells you exactly how to shift it up or down. The number inside the absolute value, which is associated there with the x, tells us the horizontal shift to the left or right. But this number is always the opposite because of this sign right here. This minus sign also means the opposite. So if this said x minus 5, it would not be an x coordinate of -5. It would be the opposite of that, of 5. So what you're going to do is you're going to take this number, but take the opposite of it. That's going to be your new x number. You're going to take this y number, and that's going to create the ordered pair for your vertex. So you can look at an equation and almost immediately determine what the vertex would be by knowing this. So let me show you how this works. Now, if we could make this huge t-chart, but let's just look up here. Here is inside the absolute value, you see the x. You see this -4? For our new vertex, we're going to take the opposite of a -4, which is 4. And for the y, we just copy and paste it. See this +2? We have a +2. So our new vertex for this equation is going to be 4, 2. So over here to the map, we go to 4, 2 to the graph. The slope in front of it right here, you see no number in front of it, so it's the invisible 1. This is where the slope would be located. And so we know we go up 1 over 1 in a V, and there would be your new function, and I didn't have to go through this t-chart. Here's what it looked like if I went through it. And notice I was able to graph it by just identifying the vertex from the equation and knowing that the slope was 1. The horizontal shift is found right here. It's the opposite of that, so it's going to be 4 to the right. And the y vertical shift is 2 up because of the +2. Okay, now look at this one. We have the same thing. We're going to identify the vertex. So for the vertex, we need an order pair, an x and a y. We take the opposite of this number for the x, which would be a +4. We take this number for the y, and our vertex is going to be 4, 2. That's the same that we just had. But there is a difference between this one and the slide before. Notice in front of the absolute value signs, we have a negative. that means your slope is a negative 1 over 1. If you remember a negative slopes go down. Positive slopes go up. So here, if we were to create the ordered pair, so if we were to actually plug in all these numbers and to make this t-chart and find the ordered pairs, we would find that this actually goes down. You still find the vertex 4, 2. This time the slope is down 1 over 1, down 1 over 1, and it goes in both directions. But it goes down. So basically, to graph these, all you have to do is identify the vertex and then figure out if it goes up or down, because the slope is going to be 1 or negative 1. What happened to the range? Well, the range on the parent function was y was greater than or equal to 0. In this one, the range is going to be y is less than or equal to a positive 2. So how do we write an equation? To write an equation, we're always going to start with this. F of x equals, and then you have your absolute value signs, the absolute value of x. So this is your basis. Just always start by writing this. Now we need to identify the vertex. You look up here for the vertex. The vertex is at 2, 3. Now I know what numbers to fill in. I take the opposite of the x and put it right here, so I write negative 2. And I take the y, which is a positive 3, and I put it here. I look to see if there is a positive slope or a negative slope. It goes up, so I know in front of it is positive, so I leave it just like that. F of x is equal to x minus 2 plus 3. So you basically start with your skeleton like this. This is what you start with. And then you find your vertex and then look to see if it goes up or down. Okay, again, let's identify the vertex. The vertex is negative 3, 1. So I start with my f of x equals, here's my absolute value signs. Take the opposite of the x, so instead of a negative 3, I'm going to write plus 3. And take the y, which is plus 1, and put it at the end. This function goes up, so I know it's positive, and I'm done. That's all there is to writing the equation for it. Let's try again. Identify the vertex. The vertex here is 6, 4. So to write the equation, I start with f of x is equal to the absolute value of x. There's what I start with. The x is a positive 6, so I write the opposite, a negative 6. The y is a positive 4, so I put that at the end. This function is negative because it goes downhill, so I put a negative sign in front. So f of x is equal to the opposite of the absolute value of x minus 6 plus 4. It's all about finding the vertex and determining whether the graph goes up or down. Now let's think about graphing the function. Again, it's all about the vertex. Look up here what you have, and you're going to think what the vertex would be. We take the opposite of the x, which is negative 2, and we take the y, which is negative 2. So our vertex is negative 2, negative 2. We know our slope is 1 because there's no number in front of it, so there's an invisible 1. And it's positive, so it's going uphill, so up 1 over 1, going both ways with a v, and we can graph it like that. I like to extend the arrows out a little longer. Okay, let's identify the vertex. The opposite of the x would be a positive 4. The y is 1, so our vertex is 4, 1. And it goes down because there's a negative slope. So this time we're going to go down 1 over 1 like this. And I have graphed that function. It's all about finding the vertex and then determining if it goes up or down. So I hope this helps you to graph and absolute function values and to be able to write the equations for them.